Hello and welcome everyone to another session in the Data Hour series. We are thrilled to be here with you this afternoon for this session full of action-packed learning. I am Deep Prasad, part of the data science team at Analytics Vidya, and we have Nikhil Raj, who will be moderating the Data Hour session with me. For those who have joined this us for the first time, a brief introduction to the Data Hour sessions is the Data Hour is a series of webinars conducted by Analytics Vidya led by top industry experts. It is a fun way to understand the concepts of data science from the leading players in the data tech domain. As the name suggests, it's 1 hour dedicated to data. We are hopeful that these sessions are going to be a great source of enrichment and value adding to our community members. Now on to our session today, classification ML model from scratch. Machine learning is a topic that has intrigued me and my friends and all of us as youngsters. Uh, m- but today we are going to speak about classification, which is a branch of machine learning that generates output by classifying the input into some category. In this data, our Kartik will guide us about the core and basic requirements of being data scientist and ML expert. Further, give us live demonstration on how we can build a classification model from scratch. Before we kick things off, I hand it over to you to our speaker. A quick recap of the housekeeping items. We are recording this session and the recording will be available on our YouTube channel. The link you can find in the chat section. Please use the Q&A section and for asking any questions you might have during the session, and we will do our best to answer them as the data hour progresses or towards the end. Lastly, we will share the feedback poll towards the end. You all are requested to kindly fill that up before leaving the session. Now on to our speaker in this data session. We have Kartik Garg with us. Kartik is an engineer and mentor and a mentor by passion, sorry. Is currently working as a data scientist at American Express, aka MX, and data analytics mentor at Udacity. He has experience of working both service and product based organization where he has created and delivered end-to-end data science and ML based solutions in the commercial services, logistics to increase the efficiency, accuracy, and utility of the data processing. Over to you, Karthik. The virtual stage is all yours.
Thanks for the wonderful introduction, Deep. First of all, I would like to thank Analytics Vidya for inviting me and have this opportunity of interacting with this community of Analytics Vidya. Indeed, I'm thrilled to be part of this session. And first of all, I would also like to take few minutes just to introduce myself so that we all can relate, right? You guys are going to spend 1 hour with me, so you should know whom you're talking to. No doubt Deep gave a good introduction of mine, but I would just like to add a few more pointers. Yes, I'm a data scientist. I have worked with two organizations so far as a full-time employee. Currently, I'm with American Express. My first organization was the Excel Services, and from the very beginning, since I have been in this industry, I have been in data science field. I have got exposure of working on different domains of machine learning. To name a few, there have been handwritten recognition machine learning problems. Then I have worked on classification machine learning problems, in which I specialize particularly. I've apart from these machine learning areas, I've also worked on reporting analytics and different areas. Right, so it's not just about machine learning as a data scientist. You get to work on different other areas as well: web crawling, software development, product management, etc. But yeah, that's a few about me. I would also like to add that this is a full-time work that I do. But apart from that, I'm also like, so as Deep mentioned, that I'm mentored by passion. So Udacity is one of the platforms which basically started my data journey. I graduated from them on did an degree in data analytics, but now I'm a mentor there, basically helping out students to proceed with their courses in data analytics as well as guiding them with their Q&As. Okay, I think I did take some time of yours, but that's what was about me. Hope we can relate. I'll try to be as elaborative, as easy as possible. This is the first session that I'll be taking, but since as per the prerequisites mentioned, we'll be talking more about the basics and more about the core fundamental areas, right? So if I talk about this session particularly, this session will be focused more on the basics of machine learning models. Like what are the core things that you at least need for building a machine learning model? It won't be more about algorithms or understanding the algorithms, but how you should proceed about tackling the algorithms or problem statements as a data scientist. Is there a technical issue that we are facing, Deep, or are we good? I saw some messages there.
Oh no, I'm replying to the. You continue. I'm replying to the.
Perfect, perfect, perfect. Let me start sharing my screen since we'll be working on a practical problem statement today. Let me know when my screen is visible. Deep, can you confirm? Or you can put your messages in chat, guys.
Yeah, your screen is visible.
Perfect, perfect. So we'll make this session interactive. I don't want it to be very one way session. It would not be, session fruitful for me as well as you guys. I'll take quick pauses in between just to quick check, and I'll also be asking some questions. And I would like you all to participate and just type anything that you understand. Right, when I ask questions, I'll try to be more elaborative over the questions that I ask, and also what I talk about in the problem statement. So yeah, ML model from scratch. So I'll first talk about what we are starting with today, the problem statement itself. So it's very important as a machine learning engineer, as a data scientist, that you first understand the problem itself, right? Don't just dive right into the data. Don't just start building the model directly. You need to first understand the problem statement because it is very essential, not just from competitive or just from creating projects, but in real life as well, right? So I spend a good amount of time to first understand the problem statement as well as the data. So this is the first core step that we need to focus on, and let's talk about it. So before I explain the problem statement, I'll take 2 minutes. I'll give you guys 2 minutes to just read through it. It's a brief description of the problem statement, and I'll summarize it for you guys. And meanwhile, if someone has any questions, just type it. 1 or 2 questions I'll try to ask of the problem statement. I'll keep a track of time as well. We are at 13:10. Cool. Just take a quick read, guys. You don't need to understand it much. I'll try to explain it for you, but yeah, just have a quick read of the data. Okay, 1 more minute to go. Okay, some guys are not able to hear. Okay, you want me to spell? Okay, okay. No issues, Jonas. I'll try. I'll basically summarize it for all you guys. Those who can read, just go through it once and I'll summarize it as well. No worries. There. I'll just take 1 more minute and I'll summarize it. Okay, we are at 13:12, so I'll just summarize it for you guys. So this is a predicting coupon redemption problem statement. So coupon redemption, what exactly is it about? So I think we have a lot of people throughout the world here and basically attending this session. So let's take an example here, right? So many of people do shop online, right? We have been interacting with various e-commerce websites wherein we do shop. So think from a perspective of a credit card company first, right? Say we all are a part of credit card company, say XYZ, and what we are trying to do here is we have a merchant. Merchant is ABC for us, right? So what are merchants in credit like business? So merchants are basically, I would say, people who do business, and the credit company basically ties up with them, and basically they are able to process credit card transactions once they are approved, right? So they are able to use their credit cards as a merchants, right? As a businesses. So ABC, if I speak in form of e-commerce websites, like take an example of Amazon, right? Amazon is one of the global e-commerce organizations. We have Alibaba as well, right? So say for example, they launch different campaigns, right? There comes different sales that happens in Amazon and these e-commerce websites. In those sales, they do give coupons, they do give different offers on these sales, right? Uh, sometimes on credit cards as well. So what we are trying to do, so I just try to relate it to certain problem statement, but what exactly we are trying to do is, we as a credit card company, we have certain merchants, right? The merchant is ABC. Apart from providing them with the credit, basically credit card function, we also help them to understand their data better, right? And take key business decisions accurately using our machine learning and analytics, right? So they have reached out to us, say Amazon or ABC in this case, they have reached out to us to understand whether a customer will be redeeming their coupon or not during a campaign, right? That is the problem statement in crux. They want to understand, using their data, past data, the campaigns they have conducted, if in future customer will be redeeming their coupon, right? So there are different like there have been discussions about different terms. Discount marketing, what is discount marketing? I won't deep dive into these areas, you can pretty much read them, but yeah, this was all about it. So now the final statement says, based on previous transaction performance data in the last 18 campaigns, so there are certain campaigns that they want to talk about. 18 campaigns, we want to predict the probability of next 10 campaigns, whether a customer will redeem a coupon or not. So in the data, we'll have basically, a customer coupon combination ID. We have to basically predict on corresponding to that whether there will be a redemption or not. I'll try to. So I think I summarized it in a very layman's terms, but let me know if you guys can still want me to rephrase it. I'll try it again. But yeah, till that time, I'll move on to the data set itself. I'll take a quick look at the chat. Okay, Ankit asks how I basically break down the problem statement. Sure. So this will be definitely a crucial learning as well while we go down this problem statement, Ankit. So I actually wanted to emphasize, let's take 2 minutes to emphasize on this particular piece, right? So whenever you come up with a problem statement, don't just dive right into it, right? As mentioned in the beginning, don't dive right into it. Don't start creating the model in the first go. First understand, take some time. I usually take even 1 or 2 days to first understand the problem statement, right? Understand it, grasp it, basically ingest it. You should be versed with each and everything of it. Try to reach out to people, try to understand it as much as possible. Then the next step should be your focus should be the data set. Try to understand the data set. Now again, I'll take a quick pause here. This might seem complex to some, this might seem simple to some, but I want us to all be on the same page. So just go through the data. This is the data that we'll be dealing with in this complete problem statement. You need to understand this very well. So take 2 minutes to understand this, and then we can move on to the next piece. Again, I'll summarize this piece as well. Definitely, I'll go through it and how I'll be breaking this down into a simpler format. So today, guys, I won't be, so just keep reading it. But yeah, today we won't be making a model with a very good accuracy. That is not the agenda here. The agenda is definitely, as one of the pointers Ankit mentioned, is how we should break down the problem statement. I'll talk more about it, what I'm trying to say more in that front, and how you should approach a problem statement. Right? Whenever you're given a problem statement, it's not directly, you shouldn't tackle a very good predictive accuracy, very good model from the very beginning. There is a definitive and a very good, better approach, in fact, I would say, than that. So you should use that. We will talk about that. What time do we have here? We are 13:17. Okay. So target is till 13:20. We'll focus on the problem statement and data, and then we'll spend 30 minutes approximately on the problem statement itself. We'll solve it. We'll try to do different iterations. We'll discuss as them, and then last 10 minutes for the final Q&A. Okay. I see a couple of questions in the chat. Okay, I'll go through them side by side. Can you share the notebook? Yeah, I'll share the notebook, Bala, after the session. Of course, I don't want you guys to go through notebook and not listen to me. So we'll be together in this session at least for 1 hour. Bear with me, and then I'll share the notebook with you guys definitely in the chat. The session will be uploaded on AV's YouTube channel. I think this should be Nurag. Maybe Deep is the better person to answer it. Any procedure? What time it is? Okay, I'll give 1 more minute to guys. Okay, this might be him. Yeah. Okay. I did realize that the chat was blocking, so I moved it away. Cool. Let me talk about the data now. So you see that here in the data, we have a train table. This is the center of the data set, right? If you see all the arrows moving it, so see, this is a design or the flow that has been shown to us of the data that is happening, right? So you can call it in any form or manner, but basically these boxes are different tables, and these arrows are basically showing how the data is flowing, right? What are the linkages that are happening? So the train data contains all the id columns as well as a target column. So in machine learning, we do call what is, so we do call the final column that we have to predict as target column, as the class column, or other names, right? So what does it mean in a simple sense of terms? Like what we have to predict, right? That is what we are getting here. Initially, this will be given to us. So here it is given to us, but when we'll be uh, predicting, will be when we'll prepare a model and when we're predicting on the data, that will be unseen data. This we have to predict on our own. So we have ID column. This ID is a combination of, let me do one thing, right? We have a description of the data set. Let me open that. It will be easier to go through that. So, okay, you guys should be able to see my screen. I have moved to a particular page where basically we see the description of the data set, right? Are you guys able to see it? Okay,
Yeah, we can
thanks.
see it.
Thanks for confirming, Deep. So this data, I'll quickly go through the data itself. I'll try to explain it. So train.csv, the first table that we saw, it contains different ID columns and the final column redemption status. So the ID column, first column is the main ID column for us. That will be throughout constant for us, which is the unique ID of coupon customer combination. So what we have to predict for? We want to predict for a particular whether a particular customer will use a coupon or not, right? So every coupon customer combination will be given here. Then we have campaign ID. So campaigns are basically different campaigns that are conducted during these when these coupons are launched, right? So there will be unique ID for campaign, discount campaign, which we can map to the particular campaign table. And then we have coupon ID. This is a unique ID for a discount coupon. Then we have customer ID. So again, coupon ID will map to the coupon mapping table. We'll talk about that. Then we have customer ID, unique ID for customer, retention status, which is the final column. Then we have the campaign data. As you can see, campaign ID is common between these two tables. So campaign ID is again present in this table, of course, is the campaign data. Then we have campaign type. I think it's pretty much self-explanatory when the campaign started and the campaign ended. Then the coupon item mapping. Again, coupon ID here. I told you that it will be linked back to the coupon ID column there. This will contain a mapping between coupon and the item ID. So items basically are when you shop on a particular, shopping store or a e-commerce websites, what are the different items that are present. So there is a possibility that different items can have same coupon, right? And there can be different coupons available for different items as well. So we'll talk about that in the next tables also. Then we have customer table. So we have two customer tables. One is the demographics table and one is a transaction table. The demographics table basically talks about different demographic aspects of a customer, which are his age range, his marital status, rented, whether he's in renting the accommodation or not, what is his family size, number of children, etc., right? Income bracket. Then we have customer transaction data. This transaction data talks about every unique transaction that has happened for a particular customer corresponding to a particular item, right? And what is the quantity of that particular, what are the quantity for the particular transaction of that item, what is the selling price, basically sales value, what are the other discounts apart from the coupon discount that is also present here. Then we have the item data. The item data particularly talks about again different information about the item id, brand, brand time, category. Then we have the test data. So this test data will not be dealing with this. So this was particular competition that happened in 2019 back. We picked this data set, but this test data was actually, you can say as the unseen data. You won't see the final column here. This is the unseen data that we have to predict for and basically submit a submission. So we won't be working on that as we cannot test our accuracy in this test data. We don't have any column corresponding to which we can test this. We have to submit and then only it was evaluated. Cool. Any questions? I'll take 1 minute to answer those questions, then we'll jump right back to the, yeah, I'll open this map again, jump right back to the problem. Guys, this is important to understand. If you have any questions to the data, just ask it in the chat. I agree with Rabin, right? Data is definitely in a very good format. In real life, it is not in good format. I can assure you that definitely. So this is I would say this is a structurized data, quite in a structured format in tables, as well as you will see different fields segregated as well. In real life, you won't be having the data, right? Definitely that happens. But again, essential for this particular session, the essential need or the essential, I would say, core thing that we were trying to focus was not just the preparation, not just one particular aspect, but as a whole, when you're tackling a problem statement, what should be your approach, right? That is what it is. With coupon redemption or not, what is the marketing objectives are gained? I do not understand particularly a question. Can you rephrase it for me, Will? Or yeah, I think Ansh basically answered it. It
Karthik,
yeah, Deep.
we can answer that in the end. We should first complete your session, and then
Yeah,
we
no
can.
issues, no issues, Deep. I think we'll be pretty much good with it. Yeah, no issues. I'll then move on to the particular problem.
Yeah, that would be best. We can answer the. We can take up the questions at the end. That would be
Yeah, I
best.
just wanted this particular piece to be clear, Deep, since it was data, right? So yeah, cool. Let's move on. So we'll start with importing the libraries. I won't go through what are the libraries. I think that is not pretty much needed to explain here, but yeah, I imported all the libraries in the one go while and basically adding them while I was preparing the model, right? So first we'll import all the files. This file again, as I mentioned, is not needed here. We'll not be looking at it, but there was a train file that we had, the first table, and other tables in form of CSVs that was imported, right? The next is assessing and understanding the data. Initially, we want to focus on first assessment now, right? Now I saw some more questions talking about how you basically break down the problem statement, right? So first you need to assess the data, understand the data. We saw the flow. Let's see what is the data exactly, how the data it is in the tables, right? So we see the train data. We have different unique values. Info is one of the very good functions that we have to basically see a brief about data itself, the data types, as well as the counts and non-null values or null values, right? So we see that the data is pretty good in this table. The data is pretty good here as well. In terms of numbers I'm talking about, right? We don't see any missing values. Particularly in customer demographics, we do see two columns, marital status as well as the number of children, where we see some missing values, right? That is one. And customer transaction data is good, items data is also good, right? See guys, one thing need to highlight here is that we won't be tackling all the tables in one go, right? It doesn't make sense. Why it is that we won't be tackling all the tables? So the essence is, when we are breaking down a problem statement, go as easy as possible. Take only those particular aspects of the data which make sense, and you can create a model. So what I'll be focusing on is an iterative approach. I emphasize on an iterative approach whenever I am tackling a problem statement, right? I first start with a very basic model, right? So let me move down. So what I'm trying to say is here, right? So this is what I'm trying to say. So whenever you are solving from a problem statement, focus on MVP's approach, right? It's also called agile in some areas. What it means is basically focus on minimum viable product. You need to first create something which makes sense. It can be as bad as possible, right? make it as broad as possible. That is actually very, very good for you when you start with machine learning. The reason for that is whenever you try to create a model and you try to do everything in one go, you will and you get bad results, right? You will be demotivated and you won't be understanding what should I do to improve it, right? So make it as bad as possible initially. Try to go as lim as possible, take minimum number of variables. So what I've emphasized on, we need to create a base model run for baseline accuracy. Set a baseline accuracy for yourself that this data at least is this much accurate uh, with the basic model that I create. Then you should analyze and transform three to column at least. Once you are done with the baseline model, then analyze and transform three to four columns at least, and then feed them back into the model and see how it is performing. I'll not talk about these two particular aspects. I'll talk about them afterwards. Then start with the required columns, right? No need to start, as I mentioned previously also, no need to start with all the columns in one go. Start with just basic required columns. Then see better merger ways. We see a lot of tables here, right? The data is not direct. I'll talk about that. Data is not direct, which can be mapped, right? So see for better merger ways and transform a data into more sensible data for the model, right? Initially, in the first MVP, you might feed it in directly, right, without any further transformations, right? But afterwards, you will need to basically transform it more so that it makes more sense, right? And then you create a model on a better data and see the accuracy parameters and iterate it as much as needed you want, right? Cool. So we saw we saw the basic information about the columns, right? We were looking at them, but what I'm trying to say here is that if we see the train column, right, and if we try to map it to tables directly, let's see which all we can map directly. I'm taking the campaign data first, right? So campaign data contains campaign ID. So there are 28 non-null values in this, right? We have just the campaign type, start date and end date. To further drill down, let's see the number of unique values that we have in campaign data. Duplicates we can see afterwards. Okay. So see, campaign data contains 28 unique IDs. That means there were 28 different campaigns that happened, two different types of campaigns that were present, and they have been different start date and their combination, basically different durations of time for which those campaigns were conducted. You need to understand this. This is important, right? Why it is? Because in the initial stage, they mentioned that 18 campaigns, there was the basically we have the data for 18 campaigns, right? For the next 10 campaigns we want to predict. So all these campaigns won't be mapping back to the train data that we have. Only 18 of these will be mapping. You need to understand this. See, it is making more sense. We didn't know this about this if we hadn't, talked about this in detail. So deep dive, understand the flow, understand what it is, otherwise you will just keep on working on the preparation, cleaning, and you won't be understanding what exactly happened. You directly move into the model and you won't be able to pinpoint where was the issue. This is one of the area we need to take care of. The second table which I'll talk about is the coupon data. So coupon item mapping, right? This contains 92,000 rows, right? So our train data contains 78,000 rows. We need to be cognizant. Then when we merge data on this, it has to be joined with the left join on this table, right? Number of rows cannot increase for those. We cannot create duplicate IDs. We need to have this one-to-one mapping here, right? So it contains more data. That is what we can see here, right? How the data looks like, let's see quickly. So here you will see that coupon, there are 1,116 coupons, right? And the item ID that are present are corresponding to it at 36,289. So what does it mean? So there are 1,116 coupons and corresponding to them, there are different item IDs. So multiple item IDs can have same coupons. That is what we can see here. But can we map it directly to the table? I think not. What will happen if we map, right? If let's take an example, if I map this data directly to the first table, right, what will happen is for every coupon ID there will be multiple items and multiple rows will be pulled in, and if I simply left join, it won't make sense because some rows will be dropped, right? Only first one will be picked up. So we need to transform it. Let's not use this column directly because in the first iteration we want to go as simple as possible, so I won't be using it, right? Going back, we see the customer demographics data. This contains customer ID, age range, all the customer information, right? So we see 760 customer IDs only here. I want to take a look at how many customer IDs did I have initially in the train data, right? To basically understand this better. In the customer demographics, we have 760 unique IDs, but here we see we have 1400 unique IDs, right? So when I map this customer demographics data, there will definitely be a miss. There will be less customers that will be populating here. See, before you start working on the data, right, and when basically you start with the cleaning steps, you need to understand why anything is happening, right? You will start working on it, you will see certain things happening, and you won't be understanding why it has happened, right? The essence of it is you need to understand how the data is, how the flow is, so that things don't come as a surprise for you when you're working on them. Cool. So we have 760 IDs. We'll be cognizant of it. When we're mapping it, there will be some loss. No issues. We'll be using this data. It can be directly mapped. We will see that it will not be populating for all the rows definitely, but some will be populating, right? And all of the customer IDs should be mapping ideally to it, right? We'll see that. So what I'm doing here is I'm selecting the tables which I'll be leveraging in the first iteration. That is what I'm trying to do. Then will go on to transaction data, customer transaction data. This contains customer transaction information. You will see a lot of data here, right? This is one of the toughest tables to basically explore here. The reason to that is there will be n number of transaction corresponding particular customer ID here. You can see almost approximately 1.3 million rows here, right? And we had just 73,000, I think, sorry, 70,000, yeah, 78,000 rows in the main data, the train data. So this data cannot be directly fed into the main data. We definitely need to transform it in a particular format. That format ideally can be grouped on the basis of customer ID, can be grouped on the basis of item ID, can be a combination of both. We need to think over it, and then only we can use it. So I don't want to do that in the first go. I'll avoid it as well, right? And lastly comes the item data. So item data contained item information. But if you see, there is no direct mapping to item data in the workflow. Let's look at here. So to train data, which will be my center of the iteration, there is no direct mapping. There was a coupon item mapping table that was mapping it to it, or customer transaction data. And I don't want to use it in the first go because I'm not using either of the two tables in the first go, right? So what I'll be using is the campaign data, the customer demographics data, and the train data in the first iteration. I'll try to go as simple as possible, create the baseline model, and then see what is the accuracy, and I'll try to improve upon it, right? I'll take a quick pause before we talk about the next pieces. What is the time? We are almost half the time. Okay. I think we can move into the next piece because it will take a lot of time. Cool. I'll move on to the next pieces. I'll try to give you guys as much as possible Q&As because then it will take a lot of time, right? So what are the minimum steps to be followed? I talk about these. I'll not talk about them again. Just go through them while I'm talking about other areas. So when you have assessed the data, you have looked at it. The next piece is you need to jot down what are the steps that you need to do, right? There are very common cleaning steps that everyone performs, but still I have jotted them down just to have a sense of it that I am taking care of them and I'm marking all of them. You should do it, you know. Many a times I'm going to GitHub profiles of many individuals just to understand how they are approaching it. When I am also in learning phase, I also learn with them, right? While implementing different problem statements. But many times what they miss is they don't document what they're trying to do. The reason to that is you fail to keep a track of what you are doing, and after some time you will be lost where what you have done, why I have done that, right? If you basically go back to it, so it is easier for you to keep track of things and how much you have progressed, what you need to do, right? So common cleaning steps to check: duplicates and missing values. We looked at missing values. We had one table where there were missing values. Duplicates, we'll be focusing on them. We'll check them again. Actually, I did miss that. If you see back, we have checked for duplicates in all the tables. This duplicacy is not being checked on particular column, but on all the rows across all the parameters. We don't see duplicates except for the transaction data. So we'll drop those rows, which is very less as compared to the complete data, but I'll talk about what to do with duplicates afterwards. Then we look for any data type issues, if any. Let's go back to that, right? Let's see if we have any data type issues. Training data, I don't think there are any data type issues. Usually for ID columns particularly, we can use object data type, the string data type that we have. In Python, it is called as object data type. We should use that, but it won't matter much, right? With the problem statement, since we won't be using them directly in any of the computations, right? The sense is that these should be constant across the tables when we are joining, right? They should be in the same format. Then comes the campaign data. In campaign data, we have the campaign type, start date and end date. These two columns are not in right format, right? That is what we see here. Then comes coupon item mapping. Here we see coupon. I think we are not using this table. Let's for it now. Then comes the customer demographics. We have marital status, age range, and object. I think this makes sense. Age range I'll be talking about what exactly is, we'll see it. Then comes rented, whether the accommodation was rented or not. It is integer, binary variable, looks good. Then family size talks about what is the size of family. Object, we'll look at it if we need to transform or not. Then number of children, again object. Then we have the income bracket, basically the salary range of the particular customer. That is also given, it is an int, seems good to us. Then transaction table, we are not using it anyways in the first go. Then we have the item data. So item data basically contains the item ID, brand, category. This also looks good to me, right? And in which ways we won't be using item data in the first go. I think we did went through this, the unique IDs. One more thing you need to do, you need to check particularly when you are going through the problem statement, is you need to see the split ratio between the class column, the values of the class column that are present. So this is a binary distribution, binary problem statement that we have. We want to see whether the coupon will be redeemed or not by a particular customer. So you see two values here. I'm talking about cell number 22 here. We are seeing the ratios of ones and zeros, right? If you look closely, we have a very, very high imbalance here, right? 77,640 rows are corresponding to zero. That means they were not redeemed. And only 729 of them are redeemed. So this is essentially a difficult problem statement because only 1% of the data, right? Only 1% data is actually, what we are trying to solve for, what we're trying to find out, particularly. And one class is basically overlapping the other class, just 1% of data, right? So we need to be cognizant of this when we are solving for a problem statement. Why I'm emphasizing on that is because it will affect which algorithm you use, how you use it, how you prepare the data, right? You need to be very, very careful when you prepare the data. You cannot feed in directly the data, and I'll show you exactly why when we'll go through first iteration, what kind of output it will show. But just to give you a sense of it, say for example, I predict all the values as zero, right? Just without using any ML algorithm, without any doing anything. Just it is very intuitive to notice that 77,640 items will be correct, right? For me, and I'll be more than approximately 99% or more than 99% accurate in my predictions. But that is not what we want, right? We want to focus on these imbalance, or I would say the real class as well, right? Which is present. So that's why we need to be cognizant, and accuracy particularly cannot be the metric for us for evaluating this problem statement. So that is also what we are able to understand from just this particular piece of uh, analysis that we are trying to do. Okay, we talked about data type issues, improper names. I didn't see any improper names in data. The reason for checking improper names is when you are using, when you're performing certain operations on columns, you will find it difficult. So it is better to basically transform them. Then outliers treatment, if any, we haven't analyzed this particularly yet. We will be doing it if needed. Then dropping all non-significant columns if necessary. So this is particular, we'll see if there is any insignificant column or something that we don't want to use, we'll drop it. Now for dropping, there are different techniques, right? We use dimensionality reduction, we use correlation and variable extension, or if we don't want to use that particular column in particular iteration due to its complexity, might be used in certain other iteration, right? That is personal choice. And if there is a need to do binning and coding or keeping of this particular values, basically this talks about feature transformations that we do. So does it required or not, right? So what are the issues that we have identified, right? So we saw missing values. I'll just quickly summarize it. We saw missing values in customer demographics table, right? So there was marital status and number of children which are missing, which is basically missing the values that we had to deal with. We need to transform basically grouping and combine data sets, right? So we saw that particular transaction table, right? It was not easy to use directly. So we need to transform these tables and then make it easier for us to understand, right? Basically easier for us to ingest in the particular pipeline that we're going to create, right? Data type issues, if any, in campaign data. So in the campaign data, we saw start date and end date, which basically were in object format, need to be dealt with. Then in customer transaction data also, we had date columns. So analyze each column distribution and then do binning and encoding. So this is again an area, because we cannot blindly do the binning and encoding. We need to look into it as well. I'll need to be cognizant of that piece. Variable creation from item. So this particular piece is something, okay, next 5 steps I'll be talking about afterwards when we'll be going through the problem statement. We'll go through first iteration. What else can be done, right? So initially I create copies of all the tables. This is an important thing to do, because afterwards you will need to, many times you will need to reiterate and go back. It's not possible. It's not feasible or not sensible to again, read the data again and again. Just create a copies of it. We have seen the data flow. So yeah, let's to move on to the basic cleaning or minimal cleaning or transformations for the MVP one that we want to do. So we saw that customer demographics table. I'll basically drop these marital status and number of children. Why I'm dropping these, right? So if you go back and if you see the demographics table, sorry, this was the one right here. Yeah, the demographics table, marital status and number of children had only even less than half of the values, right? Number of children has even less than half the values. And this, if we map back to the customer IDs, right? So we saw that customer IDs was 760 out of total 1428. So there are a lot of missing values. It doesn't seem sensible to use this data. I'll quickly drop it, right? For the first citation, I don't want to burden myself with that. Quickly drop them. So these two have dropped. The next is dropping duplicates. So in customer transaction data, we saw approximately 3,000 rows. Let's drop them. Doesn't make sense. Complete rows duplicated, not need. So just keep typing. If you see, if you differ with me on certain areas, just to keep typing them. We'll address them afterwards. But this is the first iteration that I have decided. I want to make as bad model as possible, right? So in the first iteration. Then customer data, I see after transforming. Uh, sorry. I think I missed on particular piece. Yeah, after duplicates they are removed, I just basically checking what are the number of rows that have been dropped. Then transforming and merging. So this particular piece talks about different merging that is happening between different tables. So train df was our center. We are combining campaign data. Particularly, I didn't use start date and end date here in the first iteration, right? I want to make as bad model as possible again. So start date and end date, just type in the chat window what these can be used for, how that will be useful. We'll look into that afterwards and we'll discuss over that as well. So bringing customer demographic information. So demographic information basically joining as a customer ID brought in. Okay. Then transforming transaction data before merging. So transaction data, since we had only just two tables that didn't had very less few fields coming in. So we'll do basic transformation of transaction data. We'll not pull in every data, right? So transaction data contain a lot of columns, item columns. I'm just curious about using in the first citation quantity and selling price. It's very easy, right? What I will do is I'll group by on the basis of customer ID and basically take average of the selling price per customer and average the quantity per customer of each transaction that is done. Just using it as is, let's see if it makes sense in the first iteration. Again, guys, just try to understand that we are going as simple as possible to establish a baseline accuracy. Once that is done, then we can improve upon it. But what it will, what is the benefit of it? Instead of going all, down in one go, taking a lot of time to first process and then creating a bad model, you should start with a bad model and start improving it over the line, right? It gives you a motivation that you are going the right direction. It also helps you to focus on certain areas which you might have missed when you went with all the areas, because it will give you a mental state. Okay, I have done everything. What can I do now? Doesn't make sense to me. What can I improve on? My data is not performing well. So that's why progress in a certain direction, start slow, start with certain things and then move ahead. Okay. And this particularly for guys who are, in their initial stages. I know there are there might be different data scientists and machine learning engineers who are seasoned, who are, very very basically comfortable with the data and analysis, and they can do a lot of mind calculations as well, mind processing as well. I also, spend very less time on these areas, but initially when I started, this was the key area for me to improve upon my models and create cutting edge models that I have been creating, right? So I don't want to don't want to walk you through the, model which won't make sense for you in the very beginning, and you will then again ask me, Kartik, how did you reach there? How did you create that? This is the way. This is how you need to start. This will only basically, give you the right way of improving your model one by one. I came up with different innovative approaches, and that's how you also need to improve. You need to understand, need to come up with innovative approaches, and that will only develop when you give a thought to it, right? If you don't give a thought to it, if you will just dive right into the power statement, it won't make much sense. Okay, cool. uh yeah, so where were we were basically merging the transaction table. So transaction table, I saw, I think this is not here, transaction df. Okay, I think I moved down. Yeah, here it is. So transaction table I'm grouping by on the customer ID, and for the selling price and quantity, I'm basically aggregating them on the mean. So you will see that we are basically aggregating the quantity and selling price using mean, and then we have this table with only customer ID, quantity, and selling price, and the number of rows now seem feasible because we have essentially uh, brought them down on the customer level, right? They are not transaction level or the customer level, which seems sensible to be joined with the train data that we are bringing in this particular cell, right? So here we see the train DF. The train DF is the DF that we are trying to create. We'll be using that for building the first iterative model. So quantity and selling price came here. Okay, well and good. Fill in the missing values with unknown. Okay. So in the age range, you will see. So if you see these these particular columns, these came in from the demographics table. Like I told you in the initial stages that customer IDs are missing, right, in the demographics table, and that is what you are seeing here. Now, how you deal with so many missing values? Should you drop them? Should you do some transformations? Should you utilize them? Should you analyze them? I don't want to get into that. I simply filling them with unknown in the first row, right? Let's see what it does. Even if I fill in with something by not giving a thought to it, let's see what it does so that we can improve it afterwards. Okay, let's do it. I fill it with unknown. The object columns are basically being filled with unknown here. The campaign type and the age range and the, sorry, I think it is age range and the family size. Okay, yeah, family size. These two I have filled with the unknown value because I didn't know what the value was for them. Then for rented column, which basically tells whether the accommodation is rented or not. For third piece, we don't know what it is. So I just simply fill it with 3 value, just another number, random number, doesn't make sense. Then income bracket basically talks about the income of particular individual, right? What are the basically what is the income for particular individual? So filling it with mean directly as a particular common thing that we do. I, one thing you should notice here is that we are not analyzing the data in the first iteration. I don't want to spend more time. I'm basically doing it as fast as possible so that I can have my first model ready. Okay. Then next comes the label encoding. Why I'm doing label encoding is because many columns are in object format, right? We cannot use them directly. The basic need for a machine learning model is that the data should be at least in numerical format for it to utilize, or in numerical categorical format for it to utilize, right? That is the requirement. So we are converting the columns which didn't make sense initially so that they can be label encoded and then utilized in the data. So I am creating different labels for campaign type, age range, rented, all of them basically label encoded using label encoder. So what it will do is basically if all the different values will be uh, let me show it to you. What I'm trying to say here is, so if you see train df, right, the number of unique values, so there were different unique values for these. So certain columns which had very less number of unique values, which we also call them as categorical, right, which have less number of unique values, we use them and we transform them using label encoding. That is how we do it, right? For the columns with lot of values which are numerical in nature and don't make much sense, right? So we also call them as discrete or continuous values, right? They are not categorical, discrete or continuous values. For them, the transformation needs to be different, which is called as binning. And again, it is not just binning. There can be different techniques of doing that. There can be different techniques of dealing with them. But yeah, binning is one of the common ways to do it, right? So ID columns, no need to transform. These don't make sense. Uh, common notation is that id columns should be dropped. I'll ask you guys if you see any use for the id columns. I don't think so, the id columns make sense, but yeah, these columns were categorical. These all have been transformed above, right? I think this have been transformed together. I see, removed it. Then we see quantity and selling price. These might be, so selling price should be a continuous value, right? It cannot be categorical, definitely. And quantity will be a discrete value for us. So these need to be binned. These cannot be used directly as is, right? So campaign type label, I think these are created after transformation. So we need to remove the previous values. What we'll do here is, let's just quickly do the transformation for the remaining two columns, and then we'll drop the non-important columns. So remaining two columns were the quantity and label price, selling price. What I'm doing here is, I thought of doing them, basically binning them. Again, not looking at the data, not just analyzing, just directly labeling and directly basically binning them into 5 categories. And how I am binning them? Based on their quantiles. So some people will might be knowing what are quantiles, some might not be. Just drop in a question, I'll talk about it, what are quantiles, because I think we are running short on time. So what are quantiles, I'll talk about it. But yeah, after binning them, then you move on to dropping the non-important columns. We have dropped non-important columns. What are non-important columns? The column which have been transformed, right, processed. So those have been removed. Finally, we have the data ready for feeding into the model, right? So train df, we had it. I moved the retention status back to the end. You will see that it was previously here, so move it back to the end. And just quickly look at the correlation. Now you will see here the correlation is being seen particularly. And again, drop in your answers why we are using correlation. Why do we use it particularly when we, before we feed into the model? There are different uses, right? Let's see if you guys know it. But essentially, I'll tell you what correlation is. Correlation basically checks different columns corresponding to each other as well as to the target column to see what is the Pearson's correlation coefficient corresponding to each of that combination. So there is a metric that we'll see here between all the columns, right? And what is the Pearson's correlation coefficient value here, right? Now we'll start getting the model. What I'm doing here is I'm using random forest. I didn't pick a particular model based on a particular problem statement. I just went with random forest as per my choice. Start with the model, right? Pick up any model that you want. So, okay, let me take a step back here. I'll just want to focus one more area. When you're selecting a model, don't just start, you should not focus particularly on which model to choose, because many a times in different problem as well as problem like these, which are very crucial and have the distribution of the target class is not very good, right? We saw a lot of imbalance there. Don't use it directly. Don't use any particular, don't try to fit in any particular model. Try to fit in multiple models, right? And see their performances. That is how you should do it. I am fitting random forest first, right? Let's see how it performs. Let's see what is the accuracy that we are getting. So here we are basically sampling the data. Sorry, not sampling the data. We are basically dividing the data into different values or different categories. The final column is moved here in the y and all the columns in the x, right? And then we are basically splitting the data using test train split into x train, x test, y train, y test. So these basically x train and x test is the training data for the model that we have split, and the y basically are the test data on which we will predict, right? And the ratio is one is basically one third of the data is our test data, and the rest of the data will be our train data. Okay, so cross validation is basically that we are trying to cross validate the complete data in different subsamples while we are uh, modeling, right? So as to basically see what is the performance or basically improve the model's performance, right? So we are cross validating into certain subsamples so that model is able to iterate more on and create more randomness or generalization data, right? So we are using random forest. I defined random forest here, I think so. Yeah, here is a random forest defined with
Kartik,
yeah, Deep.
we are running short of time. I really hate to break this flow, but we are running short of time.
Okay, what is the time? I see. 3 minutes more. I think we'll be done with the first model iteration, Deep. In this session, we should be able to do it. I'll talk about few things particularly, and then if everyone is okay, we can extend it for 5 to 10 minutes. Will it be possible, Deep? Can we extend it for 5 to 10 minutes or not?
Yeah, sure. We can do
Cool,
that.
cool. Let's do that. So apologies, guys. This took a bit more time, but I think these things were important to understand initially, so that you are basically able to break down the problem statement in the first go, right? So yeah, we created a random forest classifier model initially, just with the basic parameters, and then we fit it to the fit the data to the model, right? So this particular step is basically fitting it, and then we are basically testing out the different accuracy parameters. So there are different parameters like accuracy, precision, recall, and f-score. So these are different parameters. I'll explain about them if I see some questions coming in the chat window what these parameters are. But why I'm using this here is, so precision is very, very important. I'll talk about this, why we need precision here is because we need to focus on the ones here, right? They were very, very less. We need to see how many of the ones are actually be predicted. Are we leaving them out? Accuracy will be a deceiving one, right? It will basically tell me how many are the total correct predictions, right? I don't want to see all zeros be predicted, right? Recall will tell me of so precision is about the ones of total ones and false that are being predicted, like the ratio of ones right ones that model is predicting, right data that is predicting, how many ones are being predicted from that, right? Recall talks about out of the all the total ones that are present in the data, right? How many ones were predicted. And F score is basically harmonic mean of precision and recall, a single measure. So I ran this model and I saw accuracy, train accuracy of 99% test accuracy, a very good accuracy to be, deceiving one. But when I see finally my other parameters, right? So when I see my other parameters, which are precision, recall, and F score, they went out to be zero. Why it is that, we didn't prepare the model, we didn't do it very good format. We went as bad as we could, and that is what we are getting here. But this is something, a base accuracy that we got, right? We need to improve upon it. So all predicted as zeros here. We need to look at the distribution. Again, I talked about it before, but because of the distribution, this accuracy is happening. So let's do one thing. There's a very simple technique to tackle with this problem statement. Instead of feeding all the data, let's feed in samples of the data, right? In the beginning, when we fed the data, when we did the trace train split, we used all the data, right? All the train DF. Let's do different sampling of the zeros and ones and try to use that and then train the model, right? So basically model has become biased towards zeros instead of ones. We want to reduce this bias. So a simple technique is called undersampling and oversampling here, right? So what we are doing here is, so we first segregate the redempted and non-redempted values, the final column values, into two categories. And then what we'll do is we'll basically split them. We basically sample them. And so if you see this particular area, right? So we are sampling the redempted cases, I would say oversampling them from 750 to 1000 just to increase their data. So this, what it does, it will randomly sample and create more samples for me to feed into the model, right? And I picked only 5000 out of 78,000 of the non-redempted one, creating a ratio of approximately 20%, right? So that model doesn't become biased towards one particular area. Okay, that's good. Concatenated both the values together. And then instead of running one iteration, so see, if I would have trained the model on just one iteration, it wouldn't have made more sense. So what I'm doing is I am doing 10 iterations, randomly choosing for each iteration with a different random state, different set of data, and then basically running it. So this data will be repeated again and again. There's no way out for the rare class because it's very, very rare. We cannot do sampling over it. This will be same with different samples, right? Different sample that we created. But yeah, this one will be changed with every iteration, right? Which will be fed in. And the model has been defined outside so that it can learn with every iteration that we're trying to do. Now again, here when we try to do the when we try to run the model, we see that accuracy initially started with train and test accuracy started very, very, very low, right? This was very, very low. This is not something that we wanted, right? But when we started with building the model, we saw certain changes happening, right? We see precision and recall changes. Precision and recall initially was zeros, they started improving, right? So different iterations moved, and finally over all the 10 iterations, we see certain improvements, and finally we have a improved precision and recall of about 0.41%. There is some improvement, right? This is a good motivating thing for us that there is some scope for this data. It is not hopeless. It is not something that we can work upon. We can definitely work upon, but we need to break it. We need to break it into smaller subsets. You would say, Kartik, try a different model as well. Let's take XGBoost also. Similar approach, running it, then XGBoost basically performs, and finally we are getting precision recall and effort score of 0.43. Not much difference if you see, right? So had you spent a lot of time on deciding which algorithm should I choose, you would have increased your accuracy only by a certain metric of approximately 0.02%, right? That didn't make sense. That's why start big. Start with things which are solving big things for you, and then try to focus on the particular areas. So we have reached a stage where we are this much accurate. Now what to improve the data, right? Improve the data that we have prepared. One of the intuitive ways to basically prepare the data is to uh, analyze each column. Now we didn't focus on analyzing any column that we had, right? Had we been analyzing every column corresponding to other columns or the target column, that would have been very intuitive for us, because we would have been able to see the patterns of when. So let me take an example. How much time do we have here? Otherwise I'll stop here, and maybe next session we can take it up, I think. Yeah,
Yeah,
let's
we
stop
should
here.
take up the
Let's
Q&A.
yeah, let's stop here. I think we can take up the Q&A now, and
Yeah, we
another
can
session.
access the Q&A and answer these questions.
Okay, let me see. Yeah, Patrick, I'll be sharing the Jupyter notebook. Let me share it. Okay. Deep, can you read out the other questions for me till then while I'm pulling up the Jupyter and putting in
Yeah,
a chat?
sure. So this question is asked by Harish Singh. How do you decide whether you need ML implemented or just simple data analysis?
Good question indeed. So it was Harry Singh, I think so, right? If I'm not
Y-
wrong.
Yeah,
So Harry particularly, just give me a second. Let me copy this link. Okay, in the chat window, right? So guys, just try to access it and let me know if you can access it. File you should be able to ideally. So Harry Singh asks, why how do I decide
why?
whether we need to implement it is a machine learning problem or simple data analysis? So see, in the beginning, you saw that the problem statement, if I go to problem statement, it talked about it, the answer was in the problem statement or not only. So let's go back to it quickly. Yeah. Okay. So here the final question was whether a customer will redeem the coupon or not. This point was it, for me, as a classification problem statement. So you need to know bit basics about classification of Harish, to understand this. So that's why, for the prerequisites of this problem of this session was to understand basics of machine learning, basics of data analysis. If you should be able to understand whether it is a machine learning problem or data analysis. In data analysis, we will come across a problem statement, show me the trends of how of the people of transaction, what kind of transactions people do. So there would have been an analysis that you have to do on transaction data to see the transaction behavior of the people of the customers, right? There would have been a problem statement to identify which item type customers are preferring more compared to others. There would have been analysis. So that was an analytical problem where you basically need to show trends, and you need to find out particular areas. So customer would have come in, Harish, tell basically client or your leaders would have come in. Harish, tell me which items customers are buying more, so that we can offer more discounts, or we can focus them, increase their sales, or offer discount on otherwise, increase the ticketing or increase the selling of other items. So they would have told you to come up with the analysis in that problem statement. But here they want to predict something. They want to focus on future. So that's why it is a machine learning problem statement. Machine learning as well as classification problem statement. Hope that answers. Next question is of Shojibul. Is any procedure for understanding the problem? I think I talked about that, Shojibul. So I won't be going through that again. But yeah,
Yeah, we shouldn't
yeah.
we
So
shouldn't invest time.
yeah. So Sandeep asked you, what is the thing that we have to predict here? Sandeep, I think we have completed the session. This is the second
Yeah,
afterwards. What is the thing we need to predict here? Okay. So you say select some features or model, and how to select those features and classification. So you have to select the features based on the most direct features that can be implemented in the model, right? So usually you might see some columns or some tables, we might see just one table given to you, but in real life you will see lot of different tables available for you to access, and you have to first prepare or gather the data for yourself. So in that stage, just see the tables which have one-to-one direct mapping. You can leverage them directly, just join them and just start using them. Don't focus on other areas. I know there will be features which will be very important, definitely you will be missing out on them, but start with at least one model. You will at least start creating a model, and then you will find out, okay, this is not helping me out, I can drop this, I can remove this, I need to focus on other areas, and you will have something to improve upon. Okay, that is what you should do. What real-time models can we make using classification? So real-time models is not currently in scope, but you can make different type of real-time models, right? So similar models can be used in real time also. The thing would be that the pipeline that you will design will be real time, right? It will work on real time data. The model will be trained again and again. So credit and fraud detection models, right, they're working in real time. So they are different, it is a very complex pipeline, consists of assembling also, not just one model is working, right? But on the real time basis, model is being trained on the latest data, as well as it is predicting on the latest data, right? Yash asked, what are the applications for classification model? Classification models are usually used to classify yes or no. If it is a binary problem statement, if it is a ternary, there will be three values. So basically, we need to classify the data into certain categories, is what the problem statement is. How many data sets we read in this notebook? So currently we have read, I think 4 data sets, if I'm not wrong: train data, campaign data, then we had customer demographics, and the transaction data. These are the tables that we read in this problem statement. So do you propose factorizing the categorical variables or use one out encoder? Okay, so this is again a very interesting question. Person has not basically shared the name here, but whoever it is, so this is a very good question to ponder over, and I think you should hold on to that. I have asked I have mentioned these questions in certain ways we can tackle it, not particularly solving them, but basically I mentioned how we should then deal with them. So you can go to the notebook and then you will find out. But yes, I suggest that you should try out at least both of them, see what it is happening. We don't have much time, but I would have focused more on those preparation areas. So in one hot encoding, when you do, right, in one hot encoding, you are not taking into consideration the final target column. In this particular problem statement, if you see, we had very less number of values for the real class, right? So instead of directly doing the one hot encoding, I propose do kind of target encoding. That is what I would propose in this problem statement. The reason to that is the data will relate more to the final target column. You will be able to categorize and then bin it into particular categories which will make more sense and more related to the target column. That is the retention status. I hope you understand what target encoding is, but just try to find it out on Google and then you will understand it. So I have a question on base level. What is the difference between ML and data analyst? So I think we answered that before. So yeah, when I was asked, yeah, Martin, could you please explain filling object columns with unknown? So why we fill object column with unknown? So object columns are string columns, right? So you have different missing values. How do you treat them? There is no particular way. You cannot feed in particular values here. Basically, you will be tampering with the data, right? If you feed in certain values on your own. So and we cannot drop those rows as well, because there might be some important information there. Ideally, what was happening was, in the customer demographics data, we had some customers, but certain customer IDs we didn't have demographic information. So that's why they were missed. It doesn't mean that those are incorrect values. It doesn't mean that we can fill them automatically on our own. So we should fill them with a certain default value, which will essentially help us in at least processing the data. We are not tampering with the data. We are just making it easier for us to process. That's why it was filled with unknown. Ansh asks, can we aggregate using median, not mean, in merging of the customer transaction? Definitely, Ansh. So I went with, in the first iteration, I went with mean just to basically start with one thing, right? So median and mean actually, are used in different areas. You need to see the distribution. You need to see what kind of distribution. In continuous values, usually if the data is not too skewed, right, we use mean, because it will be easier for us to basically fill in the missing values, right? That's why in median is usually used for discrete values. That is what I can say. Or the values, if they are skewed, then use median, so that it can basically, it won't affect the. So see, when we have, again I would emphasize, when we are filling any kind of missing values, whether it is object type, whether it is int type, float type, anything numerical type, right, you need to make sure that the data distribution isn't affected. We didn't talk about that using graphs here, but data distribution shouldn't be affected. So you need to plot that histograms in form of line graph, plot it whatever way you want. And when you fill in the missing values, and before filling the missing values, your distribution graph should not change. Your distribution should not be tampered with when you're filling the missing values. That is the essence of it. Okay. Dropping the column with more than 50%, we should drop it in, unless the feature is not important for. Yes, you are right on that, Ansh. Again, we should not drop columns directly. We should have analyzed it. But since it was the first iteration, we wanted it to be as bad as possible so that we have something to improve upon. That's why we went with this approach. So what is binning? Binning is categorizing different values. So basically, if you see there are, so say for example, like there is a salary column, right? It can have n number of values for it. So what we are trying to do in binning is we are trying to categorize them into certain discrete categorical values. Say salary range 0 to 500, 500 to 20, 2000, something like that, based on the distribution again. Here also you should see the distribution and then you should do the binning, right? Why not logistic regression? So okay, so again, I think we didn't want to focus on the why which algorithm we are using, but I'll uh, break it down easy for you why we are not using. Just 2 minutes on this. Logistic regression has its own merits and demerits. The main demerit of logistic regression is the data needs to be prepared in certain format. It needs to be standardized as well as it needs to be normalized so that when you feed into the data in the model, it doesn't creates a bias, right? Logistic regression is very sensitive to how data is prepared. You need to be very cognizant that for example, face values, if a column contains face value as 1000 and as big as 1000, and other contains a value only in range of 0 or 1. So logistic regression will emphasize on the value, on the magnitude, right, on the column with magnitude, and give it very very high high importance, right, in the feature importance metric. So that's why you should that's why I went easy. I wanted to use tree based models, which are ensemble models, which are not too sensitive to these things, right? So that's why I went with that. Why not use class weights to balance target variable? So class weights, yes, this is again a very good approach. I wanted to talk about that, right? So this would have been covered in the second iteration. We would have created class weights based on target column. We would have created weights, and then we would have basically transformed the data to feed into the model. Ideally, yes, that is the right approach, Martin. Cannot you feel recall is more important than precision as you want to find out? I think both are important. In every problem, especially these, recall is as much important as precision. The reason to that is recall only talks about number of values covered. What if those values, so see for example, if it cover all the positive values, right? I covered all the positive values, but at the cost of predicting all the zeros as incorrect also. Say for example, I predict all the values as 1, right? My recall would have been 100% there because I predicted all the values as 1. My ones were covered, but zeros were also predicted as 1, which is inaccurate, right? So we want to take cognizant of both the aspects. That's why precision and recall should be taken together. And F1 score is a better metric, which is a combination of both precision and recall as a harmonic mean. Can someone take start if she's? Yes, definitely. I'm not. So I actually, purpose of this session was to help people who are starting, right? So I wanted to be as basic as possible here. So you have certain direction. Just follow these steps. Go to this deck again. Just follow these steps. You will have confidence that, okay, at least I can build a model. It won't be good, but you will think over it. Think over areas, logical areas you can improve, right? And then you will be able to get into this stream, right? Why do real class and classification model lead to biases? I think I explained that because model will be trained more on the other class, right? That's why. This, yeah, okay. Thanks, Dennis, for this. So how do we choose which model to work with, right? This completely depends on the problem statement as well as the data that you have, right? So Dennis, say for example, you have n number of models to work with. First of all, see which are the classification models that you should use, right? Which are the classification model that you can use with. Next, see the complexity of the data that you have. So certain models are sensitive to complex data. Basically what I mean by complex is lot of variables, lot of values, discrete values, right? So see which models, see the documentations of models and understand which models are more sensitive and less sensitive. Usually I go with tree based models because they tackle these problems very easily. And unanimously they work on most of the problem statements like XGBoost and random forest, right? Then there are all many other models as well, but yeah, these two are very much used in the industry in today's date. Just try them out, try other models as well, like logistic regression. Compare them on their accuracies, and accuracies I mean precision, recall, other parameters depending on problem statement again, and then the one which works best for you, use that. Okay.
Okay, Karthik, we will take one last question and we'll conclude. We are already way past our time.
Sure, Deepak. Let me pick one at random then. Uh,
We have that Aditi Rawat. How to choose which
hmm.
algorithm?
Yeah, I think I talked about Gautam. Let's take other question.
Okay, okay, okay,
Deepak here.
okay, okay, sure.
I think yeah, this Pranay question I'll take in. After doing the iterative process, we get precision and other metrics, how to interpret the samples and make changes in feature to get a better model. So Pranay, if you see that we didn't do a lot of processing in the data, right? So once you get the precision, once you have done one iteration, what you should do is you should go back to the data itself. You should look at the data of how you could have processed it better, right? How you would have made it more sensible. Analyze it first, right? Plot graphs or see the data distribution itself. Look at the complete data. See how the distribution is plotted using histogram or using scatter plots, plotting across other columns, and you will see certain patterns coming in usually. There will be one or two patterns that you will observe, okay, this has some relation with the target column. You plot it against the target column also. You will see that ones are being predicted across certain particular category of values, bin them into particular category. Okay.
Uh,
And then you can
okay,
then basically move on to the uh, again basically fitting the new features into the model, and that will improve your model.
okay, okay. Like we should conclude right now. Okay,
Yeah,
like
I
there is
think
a
Deep.
the yeah
Yeah,
the questions are coming again and again, and I don't think it is going to stop.
I
So
agree,
thanks a
Deepak.
lot.
Yeah,
Thanks a lot, Karthik. On behalf of Analytics Vidya, I would like to thank you for your time and for delivering such a wonderful session. And I really hated to, to break it. That the flow was so much wonderful. Like we are going through it, and
no
the
issues,
audience
no
is
issues, Deepak.
asking, audience is asking questions, and I can see the numbers are increasing still. I am sure audience found it insightful, and hopefully we can conduct more session with you in future. Thanks a
Definitely,
lot,
definitely,
everyone.
Deepak. Thank you for having me here, and thanks a lot for the wonderful audience. And hope you guys find it insightful. Reach out to me on LinkedIn, by the way. I'll try to connect with some people who would like to connect with me, and I'll try to help them out as well if they have any challenges. Right. Thanks a lot, everyone. Thank you. Have a great day. Take care.